classifications mentioned in the figure here. It can be renewables, it can be conventional energy, it can be primary and secondary forms of energy. So there are various classifications on which we can categorize energy. It can be within the green sector also, renewables, within the renewables, variable renewables, fixed dispatch renewables, within conventional sector, oil, gas, biomass. And we can see from the chart here the primary energy formats and how they are transformed into something which is more easily or which can be used with ease. So we can't directly say use maybe oil or gas. We may burn it. It will be very cumbersome and also very low in efficiency levels. So when we convert to some formats like electricity, maybe petroleum products, maybe some gas formats, biofuels, these are all extremely useful and that can be directly consumed in our different forms of consumer segments also. Now, interestingly, when we see energy coming up, every area would have a certain, you can say, resource availability or endowment. And the chart shows that huge solar resources or the solar insolation in especially in the areas near the equator and Africa and in the Middle East and also within the contours of the South Asian region. But in the next slide, as we see, the actual use of energy or solar is very limited in these areas. So it is mostly in the northern regions of the world, not the global south, but the global north. So this is very difficult to comprehend why energy is available in certain areas and not utilized in that area. Similarly, in the next slide, we can see here that the concept of energy evolves from resource potential to the final market potential. So within these two, there are two steps, technical potential and economic potential. It means that even irrespective of the resource, unless there is some technologies which can use that resource, there are some financial imperatives to use energy. And finally, there is a final demand for that energy, the sector will not get developed. And that may be the reason why you can see the resources are concentrated in certain areas, but the actual projects are put up in certain in other geographies. Now we can see in the next slide these four definitions of energy potential. So basically, when you start with resource, it is just that resources available, maybe in mountains, deserts, maybe within the oceans. But the important part is what are the technologies which are available to convert this resource to something which is more meaningful, which can be used. But then would it be too prohibitive in cost? That can be captured in the third bullet, which is economic. And finally, even if we have all the things, is there a market which can pay for it? So that captures the fourth bullet of it. Now in the next slide, we see the calorific values. So typically energy is used in different, you can say units. Somebody may say calories, joules, maybe kilowatt hour, maybe BTUs. So, but when we do a common calculation, we arrive at a common denominator in terms of TOE, which is tons of oil equivalent, which is equivalent to 10 million kilocalories. And the indicative calorific value for different fuels are given. So say for a coal, which is having a calorific value of 4,000 kilocalories, 1 ton would be equivalent to 2.5 kgs of coal would lead to 10,000 kilocalories. And similarly, it will require 2 tons of coal to generate 1 tons of oil equivalent in terms of energy. Now, also important is the concept of energy security. Are we energy secure in India? Other countries are also having a challenge in terms of energy security. So as per the common definition, it is saying that the continuous availability of energy in different formats and in sufficient quantities and at reasonable prices. So obviously for that, we need to assure that the availability of resources there. It is having technological compatibility with the local systems, and also there is no kind of a environmental challenges which we say there are externalities, so that should not be there. Otherwise we may burn coal, but somebody may be having a health issue, so that would not be in a way making us energy secure. Now in the next slide we see, and we typically think that are we energy secure? Maybe yes, maybe no, based on our perceptions and different formats of definitions which we are taking. Now, is energy related to economy? Does Indian economy needs energy? Any country, can it survive without energy? No. So we can see from the slide here in the next that there is a very strong correlation between the GDP of countries and their per capita energy consumption. We can see here US on the top, very high GDP and also very high in terms of energy use. Similarly, you can see countries on the left part, lower part, maybe India, Brazil, other countries, African countries, these are not so strong in terms of energy use, and that may be the reason that the GDP is low. It should not be construed that higher energy leads to higher economic growth, because some countries would have a good component of energy efficiency, or what do you say, that the energy intensity of those countries not so high, so they are having more productive use of energy. So example is that we are all sitting in a room and we are using lights. Suppose the lights are LED based, the output is same. Our output as user of the light is same. So we have more productivity from the light, from the same light with lower wattage, with lower energy consumption. So that would possibly help us to have a better energy utilization and lower energy footprint for that particular country or that particular area. Next slide is basically capturing the generation and consumption of energy. So which of the countries are generating energy, what forms of energy is there. So this chart is a good chart that over the last almost 6 to 7 decades, the share of oil and coal and followed by gas are the predominant energy resources. Basically, these are all part of fossil fuels. Similarly, we can see on the bottom right part, the solar, wind, other forms are not so strong. So that shows that even in spite of a lot of efforts to wean away from fossil fuels, the renewables have a limited role as of now, because the energy resources or the systems are built for the last 100 years. They're all built on fossils as a mainstay, and that is requiring a lot of efforts to push away from fossils. In the next slide, we see that though the share of certain fuels have come down, like oil is coming down, coal is also coming down, but possibly some role of gas has expanded over the last many years. But still, the challenge is that the share of fossils is in the last 7 to 8 years is still almost, if you add up all the three, oil, gas, and coal, it will be almost touching 80%. Remaining 20% is attributed to other forms of fuels, and that shows a challenge for the global economy to move away from fossils. Now, in the next slide, we see that is a latest chart which says that almost 60% is directly attributed to fossil fuels, and then nuclear is 10%, 9%, and then remaining is coming from hydro, wind, and solar power. Now, this chart basically is giving a reflection of the electricity sector, not the energy sector. So it may happen that electricity obviously is coming, a lot of electricity from these fuels, but there would be a lot of non-electric uses of conventional fossil fuels, which possibly is not captured in this slide. But overall, the electricity sector is 30% from clean power, 10% from nuclear, and remaining 60% from fossil fuels. Next slide. We can see here the huge potential of renewables. And as you can see, the big sun is there, and that possibly is having so much of energy that can run our entire systems for hundreds and millions of years. Obviously, sun is the ultimate source of energy, but still we are relying on other dirty fuels like coal, like oil and gas. So that shows a kind of a opportunity as well as challenge to move from the fossils to renewables. Next slide is who are the users? Next slide. So the users are mostly in the industries, in the transportation sector, in the residential sector. These are the users of energy. And for them to change to some clean forms of energy, including renewables, we want to have certain policy, regulatory, and financial instruments. And we can see from both the charts over 50 years apart, almost the composition is same. So that shows a huge amount of efforts we need to do to move the industries and transportation and other sectors from the main fossil intensity. Now renewables. Next slide. So we can see the renewables have really expanded over the last 7 to 8 years, and most of the contribution is attributed to solar, followed by wind. So we can see here the graph on the left part, the left y-axis, almost 4,000 gigawatts of renewables, and almost equally divided within solar, wind, and hydropower. On the right part, the additions in the year 2023, mostly solar, followed by wind, very, very nominal addition for other forms of energy. In the next slide, we see the role of different countries. So we can see a huge role of 7 to 8 countries, or the share in the total solar sector globally, led by the countries like China, US, and India, and followed by Japan and Germany. Now, in these 4 or 5 countries, none of the countries are from, you can say, equator, where solar would be very good, or even other parts of Africa. So that shows a kind of a challenge, because renewables are also growing in certain areas only. Next slide is on the wind sector. Here also the additions are limited. You can see a steady growth happening in the wind sector over the last 10 years. Obviously, wind started much earlier than solar in terms of commercial maturity, and that's the reason now their additions are limited, but they have added good amount of capacity over the last many years. Interestingly, wind is site specific, so difficult for the projects to be located across the world. Only special sites are there for wind sectors. In the next slide, we see the total renewables. So around 4,000 gigawatts are there. We can see the different numbers on the bottom of the chart: solar, hydropower, wind, bio, and geothermal. In the next slide, we see their actual generation. So the nameplate capacity is in terms of gigawatts, but the generation is coming in terms of the terawatt hours or the megawatt hours. So we can see here the share of solar and wind is almost adding up to 12%, followed by hydropower around 15%. So that shows the kind of efforts the sector has to do to further augment the supply. The next slide, we see who are the major countries which are exporting and importing fuels. So we can see here the coal production is mostly in the Asia Pacific region. You can see the yellow part, and on the right part also coal consumption is also in similar areas. Because coal being a bit bulky, it will be difficult to transit. So that may be a reason that coal is mostly from in-house coal mines, and the export or the import levels are not so big, except for few countries. In the next slide, we see the flow of oil. We can see good amount of oil coming from Middle East and also from the northern part of Americas. And or the consumption is obviously more in the Asia Pacific, which is possibly India, China, other countries, Japan, Korea, which have very low, you can say, availability of domestic coal. And we can also see a good share of the Russian Federation, which is also exporting good amount of oil in the global markets. In the next slide, we see the share of gas. Obviously, here also the consumption is high in certain areas, and gas is now preferred as an intermediate energy transition fuel because it has got lower emissions than other fuels. So that is also a versatile fuel. You can use it anywhere: transportation, cooking, power generation, fertilizers, industries. This chart indicates the flow of the fuels across the major ports as well as the sea lanes. So some sea lanes sometimes are having a challenge in terms of geopolitical issues. So there is also an issue in terms of energy security, including countries like India. Similarly, this for the gas. Next slide is what are the prices? So what do you see? The price should be same or there. So every day, every month, every moment, the price of oil is commanded by certain factors which may or may not be under our control. So certain issues are there, the price will jump. Certain issues, the price will come down. So very difficult for a country like India to adjust to change in prices because the final end price for the consumer can't be changed in such an frequent manner. In the next slide, we see the emissions part of it. So as we can see here, the major emissions globally are attributed to use of fossil fuels. Most of us know that. And the emissions are really steadily increasing. There is, you can say all of us are experiencing certain challenges of climate change in India and also other countries. In the next slide, we see the different forms of fuels which are contributing. So we can see a good amount of share of coal, oil, and gas to generate the carbon emissions. And these are increasing since the industries have come up after the Second World War and other seminal events in the human history. Next slide is giving the share of different fuels in terms of their emissions. So you can see coal is a good share, 15 gigatons, followed by oil and gas, and then the industries like cement and others follow. So we can see a good share of emissions, and that also leads to a concept of carbon budget, because when we have a certain amount of carbon which can be absorbed by the atmosphere, beyond that to be difficult. That will lead to irreparable damage to the earth ecosystems, and that is actually happening on the ground. So we have a very limited budget, and all the countries in a way want some space to grow, and that space is obviously a very limited space. Everybody wants some carbon budget. So does India also. Now we see the last few slides. So what is the way of energy transition? So we can work on almost all the sectors. It is power sector or rail, maybe transportation, buildings, petrochemicals, industries. So from almost 35 gigatons, we can make it to zero by another 2.5 decades when we work on all the sectors based on their priorities. And then this is the next slide is the concept of Kaya equation, which is very important because it captures the emissions in terms of carbon intensity and energy intensity. If we see the last two boxes, how much energy is there per GDP growth and what is the amount of carbon emissions per use of energy. So these two factors are important. One factor, effectively, energy intensity can be reduced by way of energy efficiency, and the carbon intensity can be reduced by promoting the renewables. In the next slide, we see the same thing, a kind of a decoupling happening. So the GDP is growing as we see from the chart, but the use of energy is coming down, the fossil emissions are coming down, and similarly the last two parts, like the ratios of these two, which is carbon dioxide per energy, which is my carbon intensity, and energy per GDP, which is my energy intensity, both are coming down. So that shows the global community is working hard, but more needs to be done, and possibly this course and this kind of a program is aimed at sensitizing the stakeholders, including all of us, to work towards the betterment of the environment. Next slide is the last slide, which actually captures the SDGs. Two of the SDGs are focused on energy and climate, which are SDG 7 and SDG 13. Now we'll have Namaskar. Thank you. Now we'll have a small break and we'll go to